towards the end of March this year, we saw that the internet exploded with something that we all were super excited about. What was it? It was that all of us could generate the Studio Ghibli style images out of our pictures that we gave to ChatGPT, right?
So in a very simple term, compute means the ability to process, the ability to carry out millions and billions of simple mathematical operations, and that is at the core of artificial intelligence.
So this episode of AI Square is about the compute pillar of the India AI mission. Let us explore compute from atoms all the way up to how the advanced models think.
Compute is no longer neutral. It's something very important and something that needs to be thought through very carefully.
Hello, everyone. And let's begin this episode by a short story, which everyone will relate with. So, towards the end of March this year, we saw that the internet exploded with something that we all were super excited about. What was it? It was that all of us could generate the Studio Ghibli style images out of our pictures that we gave to ChatGPT, right? But soon after, there was a tweet by Sam Altman of OpenAI, and he said that our GPUs are melting and that we'll need more capacity and more compute to make GPT function in a more efficient manner. What does this mean? Is something that we will be unpacking in today's episode. So this episode of AI Square, where argument and inquiry meets artificial intelligence, is about the compute pillar of the India AI mission. Let us explore compute from atoms all the way up to how the advanced models think. And I have with me Mr. Manish Maheshwari today. I am Bhumika Nebhnani, and together, both of us will be helping you understand compute in a very basic manner, where you understand every layer, and so that you don't have to wonder about what the news headlines are talking about. So I welcome you, Manish, and I welcome all of our audiences here as well. Let's start by the basic question of what compute means.
So lovely, Bhumika, to be on this podcast again with you. And great timing for a compute discussion. Also, as we are seeing, I think everyone's scrambling for more compute capacity. So never a better time to talk about this.
Yes.
So in a very simple term, compute means the ability to process, the ability to carry out millions and billions of simple mathematical operations, and that is at the core of artificial intelligence. Because when you are sort of running a model, what you're doing is essentially carrying out billions and billions of simple operations. So the ability to do that is the computability, and typically it boils down to the processor that you are using. And we'll talk more about processor in later part of our discussion, but that is what compute is: ability to process and run millions and billions of mathematical operations to carry out the instructions.
Got it. So let us just try and put that into a little philosophical perspective. So we are here talking about artificial intelligence, and that is different from human intelligence. So the common word here is intelligence. And if I were to put it very simply, I think intelligence is just simply arriving at decisions in a well-reasoned manner, right? So, ages ago, philosophers like Jeremy Bentham, who's one of the most prominent utilitarians, will talk about this principle called philosophic calculus. He says that that decision is the best, which helps you maximize your pleasure and minimize your pain. And then in another spectrum altogether, we have Kantian approach, which is by Immanuel Kant. He's another philosopher who talks about the means of your decision making. So whenever you are in a dilemma, you don't have to think about what's the best outcome for me in terms of my happiness, but you only have to talk about the right intent. If you're focused on the right intent, whatever the outcome is, that is the best outcome. But when we talk about artificial intelligence, what are we doing here? We are just feeding these machines with a huge amount of data and doing these mathematical operations on them for them to give us the most efficient outcome, right? But what powers that, I think, is compute. That is where we talk about compute. Right? Let us now transition to the second part of our discussion, which is the first layer of compute architecture. And let's talk about the compute hardware. What I have read is that silicon is one of the semiconductors that has powered this entire revolution, right, in terms of computing, in terms of electronics, and now artificial intelligence. So let's enlighten our audience a bit about this. Over to you, Manish.
Yeah. So before going to the specific question, I think you talked about the philosophy.
Mhm.
I think the models that we have today are predictive models in the sense that they take in billions of parameters, and they understand the relationship, and they are able to predict the next token or the next word that will come. And that's how they are progressing. So they are not inherently having a feeling or a value based decision, but a more probabilistic decision. Having said that, you can overlay a guiding principle on top of it saying, you shall not do this, or these things shall not be done, which can act as a filtering mechanism for them to not do certain things. So that's possible, and that's also programmable. Now, coming to semiconductor and the hardware, yes, I mean, the primary or the most commonly used element in all the compute infrastructure is silicon, which is the reason for that is both it has certain electrical properties and also some economic properties which makes it the ideal element. The electrical property is that it can be precisely programmed to to be switched on or off, right, based on certain temperature and other guidelines, and that allows us to build circuit logics, right? I mean, so a transistor is sort of something made out of silicon, which can be programmed to be on or off, and by doing that, you can create logic, because ultimately a computer program is a set of instructions to in zeros and one, where one is like the electricity is flowing and zero when it is not flowing. And when you build those transistors of silicon and you compress them and put it on a chip, that becomes a processor. And then sort of that is what is at the core of the entire compute infrastructure in today's age. So that's one. Now we can go slightly deeper and understand different processors, right? So one is a central processing unit, or a general purpose processor, which is good at doing multiple things, but not particularly good at, it's not particularly the best at one of the things. It is a general purpose processor, and that is what we have been using in computers. It does web browsing, it does like some kind of executing the programs as well, does some kind of compute here and there for multiple purposes. But what is most relevant today from the perspective of AI is GPU, or graphic processing unit. And the difference here is that graphic processing unit allows you to do parallel processing of simple mathematical operations at a really large scale. And the genesis of that is that these were being used for gaming consoles and for gaming users, where you were changing one figure to the next or one picture to the next. So you had to simply transpose things from one to the next, right? So it was a lot of simple mathematical operation, but it was done at scale. And in AI also, that's what you have to do, right? I mean, you have to look at billions of parameters and you have to apply weights, simply do some multiplication and some additions, and then come with the next token that has to be there, right? So GPUs are sort of the standard today in terms of the processor that is used for AI. And on top of that, some companies, particularly Google, has come up with something called TPU, which is Tensor Processing Unit. It's particularly good at machine learning. I won't get into technical details, but I think that's the sort of the evolution. But by far, NVIDIA GPUs are the industry standard when it comes to processing or compute capacity for AI.
Makes sense. So let me just summarize after every answer, right? So that it becomes easier for the audiences to absorb. We have discussed about compute as computational power, or the way in which the decision making is done by artificial intelligence models. And we have also discussed the hardware part of compute, which essentially comprises silicon chips, and those in a form of GPUs, which is the graphic processing units in the present day and age. Now, let us also talk about the software layer of compute. So, let's say I am a programmer, I'm a developer. I am using a certain programming language to give my inputs to a machine, and that is getting transformed into an outcome. So, that entire layer of where I am giving my input using Python, and then how it goes on to PyTorch, and then CUDA, and then finally is written on the GPU cores to give an outcome, is something that is helpful in understanding, right? So, over to you, Manish, for helping us understand all of that.
Yeah. So at the end of the day, a processor is simply a hardware, right? It is something made of silicon, transistors, and it is something physical, right? So someone has to write the logic, or someone has to write the instructions that should get executed on it, right? And that is the software, right? Now, but how do you do that, right? I mean, you can write a simple piece of program using a language called Python, but then you have to write everything from scratch, and that's very time consuming. And why would you even do that, right? Why would you start something from scratch when there are other people who already written amazing programs?
Hmm.
And a combination of this program, which has become very accepted in the industry, is called a framework. And those frameworks are out there, right? So the one you mentioned about PyTorch and TensorFlow are examples of frameworks which are out there in the ecosystem. So when a developer is writing a set of instructions or a program for the processor to do something, a developer doesn't start from scratch usually, right? They write on top of a framework or using a framework, and then they push the boundary in an area where they're innovating while they piggyback on or leverage what has been done already. So that's the now you mentioned about CUDA as well. So CUDA is a very specific framework that has been created by NVIDIA, which allows developers to directly write something which can then be deployed on the NVIDIA GPU chips. And that gives them the scale and that gives them the speed. And that is sort of a killer combination, right? NVIDIA GPU along with CUDA makes it sort of the best in the industry at this point in time. So that's the combination. So when you think about processor, that's the hardware. And then you need a set of instructions, a program, that's the software, or that's what the developers would write. And then the way it would get written is through a set of frameworks that are leveraged by these developers, and then they are deployed, and then they're executed and run, and that's when the outcome is produced of what you see.
Makes sense. So let us now talk about the third layer of the compute stack, the entire stack, which is the infrastructure layer. So, what I mean by infrastructure is if, for instance, I am a startup sitting in Bangalore and I want to build my own foundational model, how would I use the compute capacity? Right. So, what sort of infrastructure do I have? In which form should I have my chips? Should I rent them? Should I buy them? Do we go for GPU as a service? What is the option?
Yeah, so good question, right? I think fundamentally what you have to think as a startup is, do you rent or do you buy? And that's a function of how big you are. And what are the other criteria? Do you want to retain control and have everything with you, or are you open to giving control to someone else, right? So let's start with the three major buckets of options that you have as a startup. One is you can rent the compute infrastructure in the cloud to the one of the large cloud computing providers. There are three major ones, which is AWS by Amazon, there is Google Cloud, and there's also Microsoft Azure. And so these large players have built amazing compute infrastructure, which they are renting out based on usage to anyone out there. And you just pay for what you use. They're very good in terms of if you're a small startup, you want to quickly build something, prototype something, they're very, very good for that. But if you have a large need, they become very expensive over time because then you are paying for every usage. So the second option you have is that you can simply rent GPU as a service. You don't need to buy GPU and have it with you. You can rent, like, there are quite a few startups which are like GPU as a service startups. The major ones being CoreWeave, which has been in news lately. There's Lambda Labs, and there are quite a few others as well, like NeoCloud, right? So you can do that. And the third option is, as you become bigger, you may want to have your own compute infrastructure on premise, which is basically owned and controlled by you. In which case, you will buy those GPUs, you will get them installed in your premises, you will have the entire infrastructure, the electricity, the power, everything else needed to run them at scale. Now, those are the economic reasons and economic variables to think about. On top of the economic reason, there could also be a political or a geopolitical reason as well. For example, if you are running some critical AI application, do you want it hosted on a cloud which is not on your premises, not even in your country, but in another country, and is not governed by your rules? So would you be comfortable putting your critical defense applications or critical citizen services application on that? So that raises the question about the sovereignty and control. And that could also be the reason why, you know, you may want to have something on premise as well.
Right. Makes sense. So let me just quickly again summarize the things that we've discussed about the compute stack at large. We talked about what is compute, how is it different from the human intelligence. We talked about the compute hardware, where we talked about GPUs. We also talked about the compute software, where we talked about the programming languages and structures like CUDA and others. And finally, we touched upon the compute infrastructure in the forms of the data centers cloud compute that the different companies might need in order to build their AI models. So, this conversation therefore brings us to the AI square marker, which is the ritual that we will be doing at the end of each of our episodes. This is about one philosophy or one takeaway or one question that all of us should ponder upon. It is the responsibility of the developers and the policymakers both to think about such questions. What is the AI square marker for today is the geopolitical angle of compute. Because let's say I am a foundational model building startup in India and my chips are sourced from a country like Taiwan, designed in a country like the US. then what happens if this entire supply chain, due to some geopolitical changes, is throttled? What happens to my country's progress? These are the questions that we will be discussing in the next segment of this episode on compute. Till then, over to you, Manish, and for any last thoughts that you want to share with our audiences, after which we will wrap up.
Yeah, exactly. I think in a world increasingly defined by tech sovereignty, who owns the infrastructure is the one who will set the rules. So
Right.
compute is no longer neutral. It's something very important and something that needs to be thought through very carefully.
Thank you so much. And thank you to our audiences for joining us today. Stay tuned and do not forget to like, share, and subscribe to our AI Square podcast.
Thank you, everyone.